All right, good morning, boys and girls. So, remember that. So, here you have a P is telling you, remember for that one, you're going to have the probability of an event. That's how that goes. Okay, for your anchor chart, remember probability of an event is equal to total number of possible outcomes. And then on the top is going to be the number of favorable outcomes. Okay. So at the bottom, you would have the number of essentially your sample space, the total number of events in your sample space, and then on top would be your numerator would be whatever the possible ways of getting what you're looking for. Okay. A simple event is one event happening at a time. Remember, simple is just one. And then so today our first problem is an I do, so I'll go ahead and solve this one, and then you can go ahead just make sure you're following along. So it says you toss a coin 10 times and record 3 heads and 7 tails. What is the probability that the next toss will be a tails? So you're going to take, so you want the probability of tails, right? And so your denominator is going to be the total number of times you actually tossed the coin. So that would be 10. And of those 10 times that you tossed it, how many times did you get tails? 7. So you needed to know that you tossed the coin 10 times, and of those 10 times you got 7. So the probability would be 7/10. Okay. And so today we're talking about experimental. So experimental is when you actually do it. In the past we've been talking about theoretical. So that's like in theory what should happen. And experimental is when it actually happens. Okay. So this is we do example 1. So let's go ahead and do this one together. It says a student in Mrs. Bentley's class rolled a number cube as an experiment. Each time the cube was rolled, the number showing on the top face was recorded. The table shows the results based on the results. What is the experimental probability that the next time the number cube is rolled, it will land with a 2 or a 6 on the top face? So you want a 2 or a 6. So remember that from yesterday, what that word or means. Okay. So remember, or means to add. So that means you're going to take the probability of a 2, or not the probability of a 2, sorry. The number of times the 2 occurred, plus the number of times the 4 occurred. I'm sorry, 6. So how many times did the number cube land on 2? And then how many times did it land on 6? Okay. So that means you're going to take 6 plus 4, and that's going to give you 10. So now that you have that, you're going to put that over the total number of times they rolled the number cube. So in order to figure that out, you're going to have to add your frequency. So you would have 5 plus 6 plus 7 plus 8 plus 2 and plus 4. Okay? So you're adding all your frequencies. Okay? So I'm going to do it here on the table. So that's 11, this is 15, and this is 6. So 11 and 15 is 26. 26 plus 6 is 32. So 10 over 32. Could you simplify this? Yes. You can divide both of these by 2. That is correct. So go ahead and write it in your simplest form. So 10 divided by 2 and 32 divided by 2. And then that's going to be your final answer. Okay. It is a we do, so you can finish that one off. That's the we do part. Okay. So this is a you do. It says a student in Ms. Bentley's class rolled a number cube as an experiment. Each time the cube was rolled, the number showing on the top face was recorded. The table shows the results based on the results. What is the experimental probability that the next time the number cube is rolled, it will land on a 2 or 6 on the top face. So that one is the same one as the we just did. So you're lucky you don't have that. You do, because the numbers didn't change or anything. Okay. So we have our we do example 3. So Celeste flipped a coin 40 times. She recorded her results in a table. What is the experimental probability that the next time she flips the coin, it will land on tails? So you want the probability that the next time she flips the coin, it will land on tails. So you want tails. And this time they actually tell you she flipped the coin 40 times. So that means that you need the probability of tails. Okay. They already gave you your total number of experiments, so you don't have to add like on the previous one. And of the 40 times, how many times did it land on tails? 25 is correct. Okay. So it is not in simplest form, so you do need to go ahead and put it in simplest form. So what can we divide both of these numbers by? Yes, you can divide both of these numbers by 5. So we'll go ahead. Okay. So make sure you divide both of these numbers by 5, and that will be your answer for the we do. Okay. Then this is your last one, and it is a you do example. It says Isabella flipped a coin 75 times. She recorded her results in a table. What is the experimental probability that the next time she flips a coin, she will land on heads? So now we want the heads. So you want probability of heads. Okay. It tells you how many times she flipped the coin. 75 times. How many times did it land on head? Okay. And then, of course, you do have to simplify. So go ahead and finish that off. When you're done with your notes, you're going to go ahead and continue with your independent practice. Make sure you complete both assignments. My class, make sure you're on your best behavior for the sum. Okay. Have a good day, guys.